All right, use Robert Wadlow's shoe length, which is 47 centimeters, and height, which is 272 centimeters, to estimate each of the following. The height of a similar person whose shoe length is 42 centimeters. So what would I need to do to find this height? Okay, what's that called when I set that up? A proportion. All right, so I have the shoe length of Wadlow, which is, and that's similar to 42. And we set that equal to what? 272 over x. All right, so now what do I do? Okay, what am I going to cross multiply?
47x.
Okay.
42 divided by 47.
Divide by 47. So x equals 42 times 272 divided by 47, which gives us what? 200 and what?
43.3
And what are my units?
centimeters.
Okay. The shoe length of a similar person whose height is 170. So what am I? How am I going to set it up this time?
47 over x.
47 over x equals
170.
Now what do I do?
Cross multiply.
What am I going to cross multiply? And then?
Divide by 2.
So my shoe length is?
29.37.
Units? A family of 5 all have proportional shoe lengths and heights. The shoe length and height in centimeters of one member of the family can be written as an ordered pair 4, 252. So what is the 4 representing? Shoe length, and the 252 is representing the height. Use these dimensions to complete the ordered pairs for the rest of the family. So the brother has 24, and that's representing what? Okay? So I need to set up what? Proportions. So the first one for the brother,
4 over 24.
what's my proportion going to look like?
4 over 24 equals
4 over 24 equals 252 over x. Okay, what am I going to? 24 times 252, and then?
Divide by 4.
And
1,512.
1,512. All right, mom. What's given to us for mom? Her shoe length. So the proportion is going to look like what?
4 over 48 equals 252 over x.
4 over 48 equals 252 over x.
They're really tall.
Really small feet and they're really tall. All right, so what am I going to do now?
Cross multiply.
Okay, what am I going to cross multiply?
4x equals 48 times 252.
And then?
And then divide by 4.
Okay. So what do I have for mom?
2,074.
All right, the sister. What am I looking for on the sister? Shoe length. All right, so what am I going to set up?
4 over x equals 252
252 over 216. All right, what am I going to do now?
cross multiply.
Cross multiply what?
4 and 216 and 252.
4 and 216 equals 252x. Now what?
Divide by 252.
And what do I have?
3.42.
3.42. Is it 3.42?
Wait.
Yep. All right, for the dad.
4 over x equals 252 over
252 over
432.
432. What am I multiplying?
4 and 432 and x are 252.
4 and 432 equals 252x. And what do I do to both sides?
Divide by 252. It equals 6.
Mrs. Mauer,
Yes.
can't you just like do 252 divided by 4 and that gets 63? Then when you take the brother's 24 and multiply that by 63, you get 1,512. Can't you just do that for A and B and then divide by C and D? That way you don't have to write all of that out.
I want to see your work. You're coming up with a scale factor, and that's fine. But sometimes people get confused when you have to flip it. During a criminal investigation, a detective photographed the print of a suspect's shoe next to the outline of a penny as shown below. Use this photograph to determine the length of the footprint. So, when I'm setting up a proportion, how many things do I need?
4.
How many do I need?
3.
3, because I'm looking for the fourth. Okay. How many items do I have?
2.
And they are in this photograph, right?
Okay.
All right. What am I looking for?
Thus, length of the shoe.
The length of the footprint. So I have in the picture the footprint. And I'm trying to find the actual footprint, correct? Okay. And what else do I have in the picture? A penny. So I have a picture of a footprint and I have a picture of a penny. I need the actual footprint. What's the other item that I could use to help me find?
The length of an actual penny.
The length of an actual penny. So this right here, how many of you guys have watched CSI? Okay. So you guys have seen, they're on site, they take pictures of lots of different things, and quite often they'll put it next to something so it gives you some idea of the scale, or they'll have some sort of a measuring device here so you know how long it is, how tall it is, things like that. They don't have this in this picture. So I have an actual penny. So you guys don't have one, but draw a circle on your paper. And we can use what we have.
Why do you draw a line through the middle?
Where do you want me to draw the line? What's that?
Why do you draw the line in the middle? Why do you draw that?
How else? What other measurement are we going to get off of a penny? But it's going through the middle. What other measurement could I get off of a penny? But that is the diameter.
I was just asking, why do you draw the line? I just measure it.
Oh, I'm just, because I'll show you in just a minute. All right, so measure. You've got lots of different things to measure. So you have the footprint, which is, so I'm drawing the line to indicate that where I'm measuring. So the footprint is 5.8 centimeters in the picture. And the penny has a diameter of 0.5 centimeters. The actual penny has a diameter of 2 centimeters. So, what do I need to set up?
A proportion.
Okay. So let's set it up. What are we going to write? What's that?
Wouldn't it be 5.8 over 0.5 over 3?
Could we set it up a couple different ways?
Yeah.
Okay. So I heard somebody say 5.8 over
X.
equals
0.5
0.5 over
over 2.
2. What's another way that we could set it up? 2 over 0.5 and x over 5.8. That would also work. All right, so now what am I going to multiply?
X and 0.5 and 5.8.
Okay, 0.5 and x equals 2 and 5.8. Now what? Divide by 0.5. So x equals 2 times 5.8 divided by 0.5, which gives us
23.2.
units. Okay, so the 23.2 centimeters is his what? Shoe length, or the length of his footprint. Predict the suspect's height if the suspect is similar to Robert Wadlow. So what am I asked to find?
Height.
The height. So what do I know about the suspect right now? Okay, the shoe length. And what do I know about Robert Wadlow?
His height.
His height and his shoe length. So what is Robert Wadlow's shoe length? 47, and his height is 272. So let's set up a proportion. So somebody start telling me what I should.
47 over 23.2 equals 272 over X. Now I got 47 over 2.2.
We've got a couple different ways we can write it, right?
Yes.
All right, 272 over x equals 47 over 23.2. Or you could have flip-flopped them. You could have even put the x on top and 272 on the bottom and 23.2 on the top and 47 on the bottom. So 47x equals 23.2 times 272. Divide both sides by 47. And my suspect's height is
134.6
units.
centimeters.
What other useful predictions might the detective make from this footprint? What other things were we looking at the other day?
Couldn't you predict his weight?
Wingspan or arm span?
His weight.
Weight, what else?
Ring size.
Okay. The hand length? Okay, good. All right. We need to determine if two triangles are congruent by using the following four properties. Now we're going to do quite a bit of writing to list out how we determine if triangles are congruent. So the properties have a little bit of writing. So, angle side angle rule. We use the letters ASA. So, two triangles are congruent if two angles and the side between them of one triangle are congruent to corresponding parts of the other triangle.
Geez.
I didn't lead you on. I told you. So what's important here? Two angles and the side between them. That would be angle, side angle. Because you've got the two, you've got an angle, and then the side between the two angles. Okay? All right, side, side, side rule. Two triangles are congruent if now since it's side, 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 what do you think we're going to have to do? Three sides, exactly. If three sides of one triangle are congruent to the corresponding sides of the other triangles. So what words are important in this definition?
Three sides of one triangle.
Very good. So you have a triangle and you're going to see some sort of notation. You see the tick marks to indicate that sides are congruent, and if side lengths are different, then you have different number of tick marks. So you would see tick marks regarding three sides for this property. Angle, angle, side. Yes. Sammy is a great predictor. Two triangles are congruent if two angles and a side opposite one of those angles of one triangle are congruent to corresponding parts of the other triangle. You don't have to get sassy.
Drop it, it's sassy.
So, important words in this property. Two angles and a side opposite one of the angles. So, if you have a triangle, you have two angles. So let's say this angle and then a side opposite one of those. So this side on the bottom, on the base here, is opposite the angle up here. So that might be what it looks like for one of the triangles. You have two angles. Notice the side doesn't fall in between the two angles. It falls opposite one of them. So now last we have the side angle side rule. Two triangles are congruent if two sides. Very nice. Two sides and the angle between them
Congruent to the corresponding sides of the other
angle between those sides of one triangle. What was the rest of that?
are corresponding to the sides of the other triangle.
Congruent.
There you go, got that.
Yep. To the corresponding parts of the other triangle. So, important words in this property?
Two sides and an angle.
Between those sides. So, triangle, you have two sides and the angle between them. Doesn't matter which sides, but the angle has to fall between them.
You told your head it looks like some kind of Chinese guy.
Really?
The eyes are slanted.
Sammy. All right, determine which rule is used to prove that the triangles below are congruent. Write ASA, SSS, AAS, or SAS to identify. So number one.
SSS.
SSS.
Yeah. It was AS. Only AS. AAS. No, it's AS.
What's the difference between ASA and AAS?
Because the angles were side opposite. Because
One of them has the side in between, and one has opposite. Is this one in between?
No.
It's opposite. If it were in between, boys, if it were in between, it'd fall up here, up top. But it's not in between, so that means it's opposite, so it would be
AAS.
very nice.
And then the next one is SAS.
SAS,
And ASA.
and then angle, side, angle. Angle, side, angle. Very nice.
Good bunch of boats.